Hello dear students, welcome in our video lecture of Redox reaction. We were discussing about the oxidation state. To find out the oxidation state of an element in different kind of compound. In our previous video, we have discussed about Stokes notation method. And now in this video, we are going to see types of redox reaction. Basically, there are 4 types of redox reactions which we are going to discuss in this lecture. So take your note and pen with you and let us start. So first of all, this is the list of the different types of redox reaction. Combination is a kind of redox reactions. We are going to discuss in detail about all these kind of reactions. Combination, decomposition, then displacement. Displacements are of 2 types, non-metal displacement and metal displacement. And the last is disproportionation. Now, all these first 3 type of reactions you have already learned in your previous classes. 8, 9, in 10th standard, combination, decomposition and displacement reactions were there in your syllabus. But disproportionation is a newer concept to you. So we will discuss about all these types. So let us begin. First of all, just pause the video, make the title and write down these types of reaction. Okay, now let us start with combination reaction. So as the word suggests that combination means here more than one element. That means at least 2 elements combine with each other to form a newer compound. And it is a kind of redox reaction. Let us start with a simple example. H2 plus O2 gives H2. Now if we balance this reaction, then we have 2 oxygen over here. So we will multiply this with 2 and hydrogen becomes 4. So again we will put 2 over here. So now this is the balance, the redox reaction. And now let's consider the oxidation state of all the elements. We know very well how to find the oxidation state. Hydrogen, it is a molecule and the oxidation state of molecule is always 0. So all 4 hydrogen is having oxidation state 0. But as far as water is concerned, the oxidation state of hydrogen is +1 over here. So oxidation state changes from 0 to +1 in case of hydrogen. That means oxidation state increases. That means we can say that hydrogen is oxidized and oxidation state obviously it is 0, but in water it is -2. So it becomes 0 to -2. That means decrease. And as the oxidation state decreases, it is said to be a reduction reaction. So this reaction is ultimately a redox reaction, we know very well. But here 2 elements combine with each other to form water, and such reaction is called as combination reaction. So it is a redox reaction, but particularly 2 substances are combined together to form water. Therefore, it is a type of combination. Let us take one more example. Mg, magnesium, when reacts with oxygen, then it will give us MgO. To balance this, we will put 2 over here as well as 2 over here. Now, separate for an element having oxidation number 0. But in compound, I told you that in our previous lectures, magnesium is an alkaline earth metal. That means metal of group 2 in periodic table. And all metals in group 2 of periodic table, when they form compound, they always have an oxidation state +2. All the alkaline earth metal will always have +2 oxidation state in all their compounds. Mg +2 and O, we know very well it is -2. Here oxygen 0. So magnesium is oxidized and oxygen is reduced. Here magnesium and oxygen combine with each other to form magnesium oxide. Therefore, this is also a kind of combination reaction. There is no need to write the definition of what is combination. We know very well the concept of combination. So it is not necessary to write the definition. Just try to understand the concept only. And these are very familiar reactions to us. So there is no need to waste any time in writing the definition of combination. Combination means two substances if combined to form a compound, then such reaction is known as combination. Okay, let us take one more example. Suppose we have methane and it reacts with oxygen, it will give us carbon dioxide. And now this reaction is also an example of combination reaction. Why? Because here carbon combines with oxygen to form carbon dioxide and hydrogen also combines with oxygen to form water. If you balance this reaction, then count the oxidation state, then you will come to know that some substances are oxidized and some are reduced. So it is as simple as that. So these are three examples of combination. Now if any reaction is given to you and you are asked to find whether it is a combination reaction or not, then I hope you can easily find out which reaction is said to be combination reaction. Two substances must combine with each other. Here two substances combines to give us two products, while in previous two reactions two substances combine to give only one product. This can be helped. Okay, so pause the video, make the title, then write these three examples, then we will see the second type of redox reaction. Okay, now second is decomposition reaction. So it is totally reverse of the combination. Combination, that means combine two substances. Decomposition, that means one substance is broken to more than one substance. Let us take some example. Decomposition. So first example is H2O, H2 and O2. To balance this, we will put 2 over here. That's 2. Now water decomposed into hydrogen and oxygen gases. So one reactant is converted into more than one product, then such reaction is said to be the decomposition reaction. It is very easy. And we know very well that oxidation state of all the elements are changed while reaction proceeds. Now let us take the second example of decomposition. The second example of decomposition is KClO3. Now this is KClO3. If we heat this substance, then it will give us KCl plus O2. To make it balanced, here we have 3 oxygen, so we will put 3 over here and 2 over here. So oxygen becomes 6. In that case, potassium becomes 2, chlorine becomes 2. So simply we will put 2. Now this substance, that means only one substance, is converted into 2 smaller substances. So it is also a kind of decomposition reaction. But one more thing. If you count the oxidation state of all the elements, then let us count. Then we will discuss. Potassium, alkali metal, in all its compound, it is always in +1 oxidation state. So here K plus is always +1. And as K plus is +1, then Cl will be -1. Oxygen is always in -2. Oxygen is always in -2. Now here this oxygen, it is a neutral species, so oxidation state is 0. So you can say that here oxygen, which is having oxidation state -2 in reactant, in product it becomes 0. That means -2 to 0. This means it is oxidized. Oxidation state increased. -2, 0. 0 is greater than -2. That means oxidation state of oxygen is increased in this reaction. So this substance is oxidized. That means this substance which is left, chlorine, must be reduced. So the product chlorine contains only -1 oxidation state. Now let us count the oxidation state of Cl in KCl. if we use the classical method, then it will be like this: plus 1 plus x plus 3 minus 2 is equal to 0. Now 3 to the 6. So plus 1 plus x minus 6 is equal to 0. Minus 6 plus 1 will give us minus 5. That minus 5 goes to the other side of equal to, then it will become plus 5. So here oxidation state of chlorine is plus 5. In reactant it is plus 5, while in product it becomes minus 1. So plus 5 to minus 1, that means decreased by 6. So as oxidation state decreases, it is called reduction. So here oxygen is oxidized and chlorine is reduced. So this is also a kind of redox reaction, and here it is a decomposition kind of reaction because one substance is decomposed into two different substances. Let us take one more example. Now this is also a very interesting example. Suppose if I write CaCO3 and it is decomposed to CaO plus CO2. So it is obviously it is a decomposition because this one substance is converted into two substances. So it is a decomposition reaction. Now let us count the oxidation states. Calcium, alkaline earth metal, always in plus 2 in all its compound. So here also it is plus 2. So there is no change in oxidation state of calcium. Oxygen is always in minus 2. Here also oxygen is in minus 2. Here also it is in minus 2. So there is no change of oxidation state of oxygen also. Now only carbon is left. Now let us count the oxidation state of carbon. Here, oxygen having minus 2, we have 3 such oxygens, so it will give us minus 6. Minus 6 plus 2, that is minus 4. If that minus 4 goes to the other side of equal to, then it will give us plus 4. So oxidation state of carbon is plus 4 in calcium carbonate. Now you know very well how to count the oxidation state of any element. That's why I am rapidly writing the oxidation state of this element. If you have any doubt, then just watch the previous videos about oxidation number calculation. Okay. Now here this carbon also having oxidation state plus 4. Why? Because minus 2 to the minus 4. If that minus 4 goes to the other side of equal to, it will give us plus 4. That means though it is a decomposition reaction, but oxidation state of any element is not changed. That means this is not a redox reaction at all. Though it is a decomposition reaction, but it is not a redox reaction. There are, as I told you in our first lecture, most of the reactions which are occurring in nature are redox reaction. Most of the reactions, not all the reactions. There are such reactions which are not considered as redox reactions. So this is the text. Okay, now just write the title and write down these examples and just note down that decomposition of calcium carbonate is not a redox reaction. Okay, now displacement. Third type of reaction is displacement reaction. And there are two subtypes of displacement reaction. So first type is metal displacement. That means if metal from any compound is displaced by some other species, metal can be displaced only by metal. If you want to write, then just write down this note. Metal can always displaced by only metals. If metal are displaced, then there must be other metal who displaces this metal. So metal displacement here, let us take an example, then we will discuss. Copper sulfate. In the solution of copper sulfate, if we add zinc into it, then this zinc will displace this copper to give us ZnSO4 and copper is displaced. This is electrochemical reaction. There is a concept which is given in our textbook, but I have left that concept because after finishing this chapter, we will discuss about that. So, copper sulfate solution, if zinc rod is dipped into it, then copper is displaced by zinc and we will have zinc sulfate. So, this is the kind of displacement reaction. Copper is a metal, zinc is also a metal. So, metal displaces other metal to give us, therefore, it is metal displacement reaction. Now, let us check the oxidation state. Here, SO4 whole is -2, that means copper is +2. Element alone always have 0 oxidation state. Element alone, that means oxidation state 0. SO4 is -2, then zinc must be +2. Now let us check. Copper, which was in +2, now becomes 0. So +2 to 0. Oxidation state decreases. That means this Cu+2 is reduced. And oxidation state of zinc, which was 0 in reactant, now in product it becomes +2. So it is increased. That means it is a kind of oxidation. That is very simple. Let us take one more example. TiCl2, this is titanium chloride. Titanium chloride, when reacts with magnesium, then it will give us MgCl2 plus Ti. So again, titanium is displaced by magnesium. Now, there is one thing. More reactive metal can displace the less reactive metal from its compound. More reactive metal can displace less reactive metal from its compound. More reactive metal can displace less reactive. Less reactive metal cannot displace more reactive metal. But how can we know that this reaction is more, this metal is more reactive and this is less? So there is a series of reactivity for metal that you have also learned in your 10th class. We will discuss about that. Let me write this series today in front of you. Then we will discuss this. So I am going to write the metal reactivity series. That means reactivity of metal in decreasing order. I am going to write. Just watch it carefully. Lithium, sodium, lithium, potassium, calcium, sodium, Mg, Al, Mn, Cr, Zn, Fe, Ni, Sn, Ep, H, Cu, Hg, Ag, A. There can be more than these metals, but these are sufficient for us to know the topic, or these are sufficient to us as far as 12th standard is concerned. Lithium is the most reactive metal among all. Potassium is comparatively less reactive than lithium. And when we move from left to right, the reactivity continuously decreases. So there is a greater than sign between these elements. So these metals are most reactive metals, while these are less reactive metals. Now let us watch this. More reactive metal can displace less reactive metal from its compound. Now here we have compound of copper sulfate and zinc is reacting with it. Now compare copper and zinc. Which is more reactive? So the metal which comes first in series is more reactive, and which comes last is less reactive. So here zinc and copper. So zinc is more reactive than copper. So obviously zinc will displace copper. But if I write ZnSO4 plus Cu, then no reaction will occur. Why? Because ZnSO4, which contains zinc, is more reactive than copper. That means copper is less reactive. So less reactive metal is not able to displace more reactive metal from its. So if you remember this series, then it will be helpful to you to give the answer of such kind of question. Magnesium is the most reactive. Titanium comes after this iron or nickel. So it is comparatively less. That means magnesium will displace titanium to give us magnesium chloride. So by using this series, if question is asked, you will be able to answer that kind of question. So it is very necessary for you to remember this series. Now let me tell you how I remembered this series. Just divide it into some portions. Lithium, KCAN, MgA element, Cr. Take a break at Cr. Again 3, ZnFeNi, SnPbH, then CuHd, AgI. Now just speak in this manner or this tempo. Li, KCAN, MgAlMn, Cr, ZnFeNi, SnPbH, CuHd, AgA. So if you speak more than 2-3 times, then it will be very easy to remember this. Li, KCAN, MgAlMn, Cr, ZnFeNi, SnPbH, CuHd, AgA. Very important for us to remember this series so that we can answer such kind of questions. This is the reactivity series of metal in decreasing order. So just write down this title. This is only portion A, metal displacement. Now we are going to see non-metal displacement. But first of all, just write these examples and this point also. Okay. So this was the metal displacement, and now let us learn about non-metal displacement. It is very easy. When non-metal displacement reaction is there, then a metal is always used when a non-metal is to be displaced. So here, a non-metal is displaced by metal. You can divide these reactions in two types. Metal reaction with water. This is example of non-metal displacement. And metal reaction with acid are also this kind of reaction. So it is very simple to identify whether a reaction is non-metal displacement or not. Only two types. Water plus metal, non-metal displacement. Acid plus metal, again non-metal displacement. Let us take water plus metal, sodium. So it will give us NaOH plus H2. Water, which contains two portions, H and OH. Now this H is displaced by sodium, so it will give us NaOH. There is no need to write a bracket over here. NaOH. And this hydrogen is SH. Now if we want to balance this chemical reaction, then we have to take two water molecules. In that condition, we should take two sodium. So it will give us 2 more of NaOH. All these portions are 2. So 2Na plus 2OH will give us 2 NaOH. And this 2H will give us H2. So this is an example of non-metal displacement. Hydrogen is non-metal with respect to sodium. And this sodium metal displaces this hydrogen to give us sodium hydroxide. One more example. H2O plus calcium. This is also a metal. And calcium, if displaces hydrogen, again 2 moles of water will give us 2H, 2OH. These 2OH will react with calcium to give us calcium hydroxide. This is calcium. and these two hydrogens will give us. So if water is reacting with any reactive metal, then it will always give metal hydroxide and hydrogen gas. These are the example of non-metal displacement by metal. Now, two more examples in which acids are there. Suppose if we take HCl and sodium, so this hydrogen is displaced by sodium, then it will give us NaCl plus H2. Again, we will put 2 HCl, 2 N, will give us 2 NaCl and 1 more H2. So this is acid and metal, but metal should be highly reactive. Mostly copper, mercury, silver, and gold. These metals which are at the last of the reactivity series, that means they are less reactive metal. If such metals are added into water or acid, they will not displace hydrogen. Reason? I think you know the reason why those metals are not able to displace hydrogen. Because those metals are situated after the hydrogen in reactivity series. And the metals which are situated after hydrogen are not able to displace hydrogen from the compound of hydrogen. It is very simple. Okay, one more example. HNO3 plus calcium. So again, this calcium will displace this hydrogen. We will give 2 mole of HNO3 and it will give us calcium nitrate. And so these are the examples of non-metal displacement. Here, non-metal is hydrogen in all these reactions and it is displaced by more reactive metal like sodium and calcium. You can consider the reaction of Li, K, Ca, Na, Mg, Al, Mn, Cr, Zn, Fe, Ni, Sn, Pp. Yes, so એના પછી જ આવી જાય. So these are the examples of non-metal displacement. So pause the video and let these examples. Okay. So we have discussed the 3 types of redox reactions out of 4. The fourth one is disproportionation. Now, disproportionation is a very special kind of reaction. We will need that word in 12th standard also, because there are so many displacement reactions in our series. So we will discuss about displacement in our separate next video. In this video, now we will conclude this video. 3 type of redox reactions we have discussed so far: combination, decomposition, and displacement, with some examples also. Now these are the basic kind of reactions and they are very simple. If 2 elements combine, combination. If a substance is divided into more than 1, 2, or 3 substances, then it is decomposition. And if some elements can displace the other elements, then it is a displacement reaction. They are divided into 2 subtypes: metal displacement, in which metal is displaced by more reactive, and non-metal displacement, in which non-metal is displaced by a reactive metal. So this is all for today's video. Just try to remember all these kind of reactions, try to understand, make your concept clear about this kind of reactions. If you like the video, then press the like button. And if you have not subscribed yet, then subscribe our channel, press the bell icon as well. Till we meet next time.